Halley was aware that the AU was one of the most fundamental of all astronomical measurements. Johannes Kepler in the early 17th century had shown that the distances of the planets from the Sun governed their orbital speeds, which were easily measurable, but no one had found a way to calculate accurate distances to the planets from the Earth. The goal was to measure the AU, then knowing the orbital speeds of all the other planets around the Sun, the scale of the solar system would fall into place. However, Halley realized that Mercury was so far away that its parallax angle would be very difficult to determine. As Venus was closer to the Earth, its parallax angle would be larger, and Halley worked out that by using Venus, it would be possible to measure the Sun's distance to 1 part in 500. But there was a problem. Transits of Venus, unlike those of Mercury, are rare, occurring in pairs, roughly 8 years apart every 100 or so years. Nevertheless, he accurately predicted that Venus would cross the face of the Sun in both 1761 and 1769, though he didn't survive to see either. Inspired by Halley's suggestion of a way to pin down the scale of the solar system, teams of British and French astronomers set out on expeditions to places as diverse as India and Siberia. But things weren't helped by Britain and France being at war. The person who deserves most sympathy is the French astronomer Guillaume Le Gentil. He was thwarted by the fact that the British were besieging his observation site at Pondicherry in India, fleeing on a French warship crossing the Indian Ocean. Le Gentil saw a wonderful transit, but the ship's pitching and rolling ruled out any attempt at making accurate observations. Undaunted, he remained south of the equator, keeping himself busy by studying the islands of Mauritius and Madagascar before setting off to observe the next transit in the Philippines. Ironically, after traveling nearly 50,000 kilometers, his views were clouded out at the last moment, a very dispiriting experience.